In this video, we will write equivalent fractions. Equivalent fractions have different numerators and denominators, but represent the same value. For example, 1/2 is equivalent to 2/4, since 1/2 and 2/4 have the same value. In my first example, I have 3/5, and I want to write an equivalent fraction that has a denominator of 35. Now, the only thing I can do with a fraction so as not to change its value is multiply the fraction by 1, since any number multiplied by 1 gives itself. So I have the denominator 5 that I want to be a 35. So if I multiply by 7 over 7, I'm multiplying 3/5 times 1, and I'm not changing its value. So when we multiply fractions, we multiply across the numerators and across the denominators. So 21/35 is going to be my equivalent fraction. In the next example, 6/7, we want to have an equivalent fraction with denominator 35x. So I have to look at what factors are missing on the left to make the denominator match the right. So I have 7, but I need 35x. So if I multiply 7 times 5x, that will give me 35x. Therefore, I have to multiply the numerator by 5x as well. So when I multiply across the numerators, I'm left with 30x over 7x. And you'll recognize that if I reduce the fraction on the right, it's going to give me 6/7. Next, I have 4 over 5x. Now I have 5x, and I want my denominator to be 10x. So what am I missing on the left to make it look like the right? So you see that I already have the x, so I'm not going to multiply by x again. So I have 5x. If I just multiply by 2, so I'll multiply by 2 over 2, I'm going to be left with 8x over 10x. Now, do you see why I needed the x here and not here? So if we want the denominators to match, we have to multiply just by the factors that are missing on the left to make them look like the right. So I have 2 over 7x. I want my denominator to be 14x. You'll notice that I already have the factor of x. So what I'm missing on the left to make it look like the right, in order to get the denominators to match, I need to only multiply by 2. So I'm going to multiply by 2 over 2, and that's going to give me 4 over 14x. And again, 4 over 14x would reduce to 2 over 7x. Next, I have 5 over 6y, and I want my denominator to be 30y. So I have to look at the factors that are missing on the left to make it look like the right. So I have 6y. The y's I already have. If I want to make the 6 look like 30, I multiply by a factor of 5. And so I'm left with 25 over 30y. Here I have 8, and I need 16k. So I'm going to multiply by the factors that are missing. So I'm missing 2, and I'm also missing the k. So this will give me 16k. And I have to multiply by 2k over 2k, so I'm multiplying the entire fraction by 1, leaving me with 10k over 16k as my equivalent fraction.